All right, welcome back. We are on 8.2 today, and I'm also going to record 8.3 on the same video. So whether it gets split up into 2 days or not, we're just going to go through both of them right now. So let's get this thing started right here. We got a couple goals, and I'm pulling them up on my end as well. But 2 things that we're going to fill out for goals today. Trying to get my stuff set up here, just a quick second. So get settled in. Goal number 1, we are going to basically be using the distributive property here. We are going to distribute a monomial. And again, yesterday we talked about what a monomial was, and basically what a monomial is a number and a variable, or maybe more than one variable, and all these things are being multiplied together. As soon as you see plus signs or minus signs, then it's no longer a monomial. So that's just a little bit of a review. We're also going to factor monomials. Factoring is something that you guys have seen before. I remember when I taught 8th grade math at Memorial, we definitely went over factoring. So this is something you guys have seen, even though it might have been brief. So hopefully it doesn't go too horribly. I think it's actually going to be pretty good today still for 8.2 stuff. And then when we get to 8.3, then stuff gets a little bit more tricky. But for 8.2, to start here, basically we have something outside of the parentheses and then 2 things inside the parentheses. And we are just going to use the distributive property. Now, when we use the distributive property, we are multiplying, right? So basically what we're going to get as a result is 2 terms. One is just multiplying these first 2, and then one is multiplying the 2x and the 1. Now, if you remember multiplying, when we have common bases, we have to add our exponents. So if I do 2x times 3x, that's actually going to give me a 6x squared because I added the exponents. That's just one of our rules for exponents. We have to add our exponents there, and we got 2 because 1 plus 1 is 2. Next, we're going to multiply 2x times 1. That's pretty simple. I also have to put my plus sign in between. Since there was a plus sign there to start, we have a plus sign. I'm going to do a better job of drawing one here. But there is a plus sign in between there. 2x times 1 is just a 2x. And that's it for the first one. Moving on to the second one, we have a negative x to the 3rd power, which is really the same thing as a negative 1x to the 3rd power. But that's going to get multiplied into all of these things now. So a negative 1 times a 9 is a negative 9, so that's where we got to start. And then we are basically, again, multiplying with common basis, so we add our exponents. So that would be x to the 7th. Moving on to the next one, we have a negative 1, which is out front here. I know you can't see it, but there's a negative 1 there, times a negative 2. Well, negative 1 times negative 2 is positive 2. So this actually, again, becomes a plus symbol. There's a plus symbol there. So we have a positive now, even though these were both negative. Multiplying them makes them positive. We would have a positive 2x. If we add our exponents, we would have 6. 3 plus 3 is 6. And then our last one here, negative 1 times 7 is a negative 7. So I actually am going to need to erase that plus sign on this one. Because negative 1 times 7 is negative 7. And then we still have that x to the 3rd there that we're just going to have tag along. Okay, so that's the second one. Again, at any point during the video, if you're confused, maybe just raise your hand, and the sub can definitely help you out with this stuff. So, all right, next. Now we're going to be multiplying, distributing this 5n to all 3 parts. So 5n and 3n to the 3rd, that's just a 15n to the 4th, because 5 times 3 is 15, and I'm adding my exponents again, because I'm multiplying. If you're multiplying, you add your exponents. The next one, 5 times negative 1 is negative 5. So that's just, there's a negative 1 there again that you can't really see. So if I erase everything quick, we're on this step right now. 5 times negative 1 is negative 5. And then n in n to the second power is n to the third. In my last step here, 5 times 8 is 40. That's positive. And again, the n's just going to have to tag along there because there's no n on this side to multiply it with. So that's it for that. All right, next, what is the GCF? Now, when you see the GCF on your page, you got to be thinking greatest common factor. So basically, I need to figure out in this term, and this is a trinomial, there's 3 terms. In all 3 of those terms, what can we pull out? Maybe take a second to pause the video and think about what factor, what number, first of all, can we pull out of all 3 of those? Okay, so the number that I came up with was 5. I can pull a 5 out of 5, I can pull a 25 out of, I can pull a 5 out of 25, and I can pull a 5 out of 45. So that's going to be basically the number. Now, we also have to think about the variable. And this is where things get a little bit tricky sometimes. I'm going to erase my circles here so I can see. So there's 3 x's in the first term, there's 2 x's in the second term, and there's 1 x in the third term. So basically what we're saying here is that each of those terms has an x to give up. So this is what it's going to look like. We're basically doing reverse distributive property on this. This is just the distributive property except backwards. So if I wanted to make it look like what we were just doing up here, right above it, this is how we're going to have it set up. This is what is going to get distributed into everything to get this. The 5x is going to, like if we were to distribute, what would be left over here? So basically my question for the first term is 5x times what gives me 5x to the third power. So this right here, our GCF times what, and that's going to go in here, will give us that 5x to the third power. Well, the answer is x squared. If I take 5x times 5x squared, I will actually get the first term that you can see over here. It'll be 5x to the third. Let's go through the next one. Now, I need 5x times something to get me 25x squared. So what would that something be to get me to 25x squared? Well, I know 5 times 5 is 25. I'm actually going to put a plus symbol in between there. 5 times 5 is 25. And we have an x. We have to multiply it by another x to get x squared. Okay? And then the last part here, 5 times what gives me 45? That would be a 9. And then they have an x here and we have an x here. So we're actually not going to attach an x to that 9 because 5x times 9 is 45x. And that's it. Let's see here. Oh, yeah, I guess all this stuff was supposed to go on the next line down when it says factor the polynomial. That's what we did. We factored it. That's what, I'll draw an arrow and show. That's what we just did. That's factoring the polynomial. When we say factor, basically it means it wants us to separate. Okay, we're going to be doing that a lot. So we're going to separate our polynomials into smaller pieces, basically. So we're going to need this for some stuff. You're also going to need to distribute for some stuff. So these things that we just did are the exact same thing, except one of them we did in reverse. I think another example is probably a good idea. So let's keep scrolling down here. It says, what is the GCF? All right, so when we want GCF, again, up top here it was 5x, and maybe we could have written that. it was 5x. So for this one, what can we pull out? Well, first of all, I need a number that goes into 3, 9, and 12. And don't even worry about the negatives. I just need the 3, the 9, and the 12. A number that goes into those would be 3. I don't think there's any bigger numbers that go into all 3 of those. Can we pull out an x? The answer is yes, we can. Because this one has 4 of them, this one has 2 of them, and this one has 1 of them. So they all have 1 to basically give up. Okay? So when I factor this, that 3x is basically just going to go out front, and then we got to figure out what's going to be left inside. If I pull a 3x out of 3x to the 4th, well, I pulled out the 3, I pulled out one of the x's, there's going to be 3 of them left over. So put x to the 3rd there. Next, if I pull a 3 out of a negative 9, what's left over? Negative 3 would be left over because 3 times negative 3 is negative 9. And I pulled out one of the x's, so there's only one x that's left over, so I would just put an x there. You could put x to the 1st, but it's not really necessary. And then my last step here is if I pull a 3 out of negative 12, I'm left with a negative 4. And I've pulled out the x as well. There was only one x to give, and it's in the front right now, waiting to be redistributed if needed, right? We could redistribute those in, and it would get us the same thing. So that's a good way to actually check your work. If you wanted to distribute it back out and see if it worked, you could do that. Next one, it says, what is the factored form of this? Well, we need to figure out what our GCF is first. I think a 4 goes into all of those things. And I also see that each of them has one x to give up. If this one, by the way, had a 2x squared, everybody looking up here, if this had an x squared, then we could actually take 2 out of each. But it doesn't have 2 to give, so we can't do that. So, if we pull a 4 and an x out of this, well, the 4 would be out, and one of the x's would be out, so we just have x to the 4th left over. Next, if I pull a 4 out of negative 24, what's left over? Well, it'd be a negative 6, because negative 6 times 4 is negative 24. And we pulled out one of the x's, so we have x squared. And the last one here, if we have an 8x and we pull out a 4x, we're going to just be left with a 2. And we pulled out the x, so we don't have an x left over. All right, this might be a good idea, a good time to pause the video and just see if there's any questions on anything that we just went through right now. I'll let you take a minute to pause. All right, we're going to move on here. Actually, I'd like you guys to try this last one on your own. And here, we're going to pause the video for just a second, let everybody have an attempt. And then when you have tried it on your own, the sub will tell you guys to talk with the person next to you and see if you guys got the same thing. So do it on your own, then check with a partner, and then we're just going to go through it together. Okay, go. All right, let's get back to it. Factor the polynomial. First thing I got to think about is what number can I pull out? And in this one, I can pull out actually a negative 6. So if you caught that you could pull out the negative, all of them have a negative. So that's actually a good idea to pull out a negative on all of these. What you're going to want to end up doing when you're doing the GCF, if you look up here, all of these first terms that are in our parentheses are all positive, and that's kind of what you need. I'm just telling you for now, that's a really good thing to have kind of look at as you're going through these, because it makes life easier in the future. So I pull out a negative 6, and basically, I guess on this one, I said this on the last one too, we can pull out 2 x's out of each of these terms because they each have 2 to give up. So if I pull out x squared, now we got to figure out what's left. Well, in the first term, I pulled out a negative 6, and there was only a negative 6 to give, so that's basically gone. And then what's left would be, well, I can pull out 2 of the x's out of the 4, so we're going to be left with just x squared. On the next one, if I pull a negative 6 out of 18, this is actually going to become a plus because I pulled out the negative with the negative 6 in front here. So it's going to become a plus. So if we pull out a negative 6 out of negative 18, we'll be left with 3, a positive 3. And I pulled out 2 of the x's, so there's only 1 left. And then the last step here, if I pull a negative 6 out of negative 12, that becomes a positive as well. And basically we're left with a positive 2, and the x's are gone because we pulled out x squared and there was only x squared in the problem to begin with. So that's the answer for that one. Make sure you got that right. If you did get that right, maybe help those at your table that didn't get it right. And if you didn't get it right, go ahead and ask your table now for help. And if your table didn't get it right, then go ahead and ask a teacher in the room. That's it for the lesson, though. Make sure you guys have these down before you start the worksheet. Ask questions if you have them.